Hey students, so today we're going to be talking about the three forms of quadratics: vertex form, factored form, and standard form. I've gone into detail about these three in prior videos, so this is more of an overview, but I'll be referencing some of the prior videos if you haven't seen them yet. So we're going to do an overview of how their graphs are all related, and we're also going to be algebraically converting between the forms. So I have some different examples here in vertex, factored, and standard form. And these three specific equations actually all form the exact same graph. You can't really tell by looking at them, but if you were to graph them on a graphing calculator, you would see that they're all going to sit on top of each other. And this is the graph that these three actually create. So I'm going to talk about how these relate to the graph. So with vertex form, we're able to identify what the vertex is from this equation. And we can see from the graph that the vertex is down here at at 1, -9. And in the equation, we can see that there is a -1 and a -9 there. And remember from previous videos that this -1 here, we actually take the opposite of it to tell us the x value of the vertex, and then the -9 tells us about the y value of the vertex. And whenever something is inside parentheses, we're going to take the opposite of it to tell us about certain points. We're going to see that with the factored form equation here as well. The factored form equation tells us about the x-intercepts on the graph. So looking at the graph here, I can see the x-intercepts are here at -2 and here at +4. And we can see in the equation here that that is flipped from what is actually in the equation. Just like how these are in parentheses as in vertex form, we actually want to take the opposite of them to find the x-intercepts that are actually located on the graph. And we did talk more in depth about this in a prior video, but I will link that if you need it. Now the standard form equation, we haven't talked about this one as much yet, but this actually tells us about where the y-intercept is located. So taking a look at the parabola here, we have the y-intercept here at -8, and that's actually shown in our standard form equation right here. The -2 isn't very clear where that's located in the graph, but the -8 does tell us where the y-intercept is located. And this is actually related to the equation that we know about linear equations in standard form, y equals mx plus b. Remember that number that we add on to the end is our y-intercept with linear equations? The same is true for quadratic equations. And this is basically an overview of what the different forms of quadratics tell us about specific values on the graph. Keep in mind that we also discussed whether the graph is going to be flipped upside down. So we'll do some examples of that here next. So which equation can represent the quadratic? Select all that apply. And it looks like we have some options here, both in vertex form and in factored form. The top three are in vertex form, and then the last two are in factored form. And remember, the vertex form tells us about the vertex. So let's take a look at this graph. Where is the vertex at? So it looks like it's shifted over to -4 for the x value and down to -4 for the y value. So we want an equation that is going to have -4 and -4 as the vertex. And the one that I see that has both of those there is actually option 3. Now, option 3 has inside the parentheses the opposite of our x value being +4 in the parentheses and -4 as our vertex x value. And then our y value is just regular -4. So this is one of our correct equations. The top two are not correct. And then with the factored form equations, remember this tells us about the x-intercepts. So where are the x-intercepts? They are at -6 and at -2, just reading the graph. So would that be option the second from last or the last option? Well, that's going to be, remember they have to be opposites when they're inside parentheses, so that's going to be the second to last option there. And those are the only two equations that represent this quadratic right here. Don't forget that when we have a negative a value, when we have a negative in front of the equations, it's going to be flipped upside down. But let's try this one too. We have the vertex up here. I'll just identify that first. It's at negative 1, 4. And so let's see which vertex equation that's going to match with. I clearly have these two options here. Many might incorrectly select this one because they see that negative 1 and that 4, but remember it has to be the opposite when it's in parentheses. So the first one is going to be one of them. And then we also have the x-intercepts at negative 3 and positive 1. And from the two options I have here, I want to do the opposite inside these parentheses of what I'm seeing on the graph. And so that's going to be the last option to work for us too. Okay, so next we're going to be converting between the forms of quadratics. And we're going to do this algebraically. So I have my three different forms here, and I'll show you how to go between them. We'll start with a very quick review of going from factor to standard form. So when you have a factored form quadratic, I really like to use the box method to solve this one. So I'll do this example really quickly. We have our length and our width of the box. We have x plus 2 and x minus 4. X times x is x squared. X times negative 4 is negative 4x. 2 times x is 2x. And 2 times negative 4 is negative 8. Then we want to write that out in standard form. So we have our x squared value. Negative 4x plus 2x is negative 2x minus 8. And if you recall, this is actually the same equations that we used in the graph earlier. So this is the standard form equation that we had earlier in the graph. Now, if you want to convert between standard and factored form, then you have to do some factoring. We talked about that in a previous video too, where you start with your standard form trinomial, figure out what's going to work in the box to end up getting your two sets of parentheses there. Next, let's talk about vertex form. So we have the original equation there, and a lot of people are tempted to incorrectly distribute this square to make it x squared minus 1 squared, but that actually doesn't follow the definition of squaring something. When you square something, you multiply it by itself. And so if I multiply these by itself, the base of that exponent, it ends up looking like a factored form kind of, except for we have this minus 9 on the end. So I'm going to go ahead and use the box method to solve x minus 1 times x minus 1. We'll deal with the minus 9 later. So we have x minus 1. I'll make sure I'll attach that negative to the 1 so I don't lose it. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And so the standard form, or I guess the simplification of this, is going to be x squared. Negative x minus x is negative 2x plus 1. And don't forget about that minus 9 over here. We have to make sure that we include that in there. And so we'll just subtract it onto the end. So we end up with x squared minus 2x, and we'll combine like terms there. 1 minus 9 is negative 8. And there we have the standard form equation, again, of what we had earlier. Now, lastly is converting between standard form and vertex form. So there is a process to do this called completing the square. I'll link a video to other teachers that have taught this. It is a little bit lengthy, but I would actually encourage you to look at the graph of a standard form equation. A really great website that I like to use is this graphing calculator site that Desmos.com provides, and you can graph this equation right here, identify the vertex after graphing it, and then be able to match the equation with the vertex form. That's totally fine for the purposes of what we're doing in our class. So if you go to that link, you can type the equation into the equation editor up there, and then we have a graph of our quadratic. And you can even click on special points on Desmos. It tells you that the vertex is at 1, -9. From there, you just need to correctly identify which equation is going to match the vertex form. So with the vertex at 1, -9, our A value is just going to be positive because it was pointing up, so we don't have to substitute anything in for that. X, we're going to do -1 because we want to do the opposite inside those parentheses there. Then we'll square it as it's written up here, and then we add on the Y value on the end. In this case, it's negative, so we'll subtract it on. And that is how you can write the vertex form of an equation from standard form. Again, to do this algebraically, it's called completing the square. And I'd encourage you to watch some videos about that because there's plenty of them if you're interested in learning how to do it algebraically.